For many students, this is the reaction to chemistry.
No! God, please, no! No!
But it doesn't have to be that way. In these videos, I want to help you get an A in your general chem class or 5 on that AP exam by making the process of learning chemistry as fun and as easy as possible. After all, any career path involving science, whether it's medical doctor, marine biologist, or in my case, chemical engineer, specifically in biotech research and development, means that chemistry is a necessary evil, so it's absolutely worth building a strong foundation early on. And who knows, by the end of your general chem class, you might have the same reaction that I had towards chemistry, which was,
yes, science!
So what the heck is chemistry anyways? Chemistry is the study of matter. How to identify matter, how matter behaves in the universe, and how we can ultimately utilize matter for our own needs. And matter is anything that takes up space and has mass. Really, any physical thing you can think of in the universe, particles, humans, the earth, stars, all of it is considered matter. A pure substance, or you'll hear scientists just use the word substance for short, is matter that has constant chemical composition and properties. Examples would include oxygen, water, and table salt. Substances don't vary from sample to sample. Therefore, me breathing oxygen in my room here would be the same as me breathing oxygen in another country because all oxygen molecules will behave the same. So these are all kind of general and very broad definitions. So scientists have organized all of this matter into different categories so we can actually make sense of all of it. And in this video, I'll break down everything you need to know about the basics of matter and how we organize it. First, I'll go over the building blocks of matter. Second, I'll go over the classifications of matter, and third, I'll go through the properties of matter. Now, I will warn that this first video has a lot of vocab words for you to learn. So I made flashcards via Quizlet, and I've linked that in the description below so you can go ahead and practice all of these definitions after watching the video. And this is just an introduction focused on the basics. So these descriptions are sufficient for now, but we will certainly dive way deeper into each of these terms in later videos because after all,
mastering the elements takes years of discipline and practice.
Alright, so number 1, the building blocks of matter. All of the ordinary matter in our universe are comprised of these things called atoms. They are considered the fundamental building blocks or the smallest unit of ordinary matter. There are currently 118 unique types of atoms that we have discovered, called elements, which are conveniently organized on the periodic table. Elements are the simplest substances you can find in chemistry because they can't be broken down into simpler substances by chemical reactions. And so atoms are the smallest unit that will make up elements. However, single atoms like hydrogen or oxygen atoms are actually really rare in nature. And so 2 or more of these atoms will bond together to form molecules. And then atoms from different elements bond all the time with each other, like when 2 hydrogen atoms and 1 oxygen atom will bond together to form water molecules, H2O. Now you'll also hear the word particle, and this just refers to the smallest portions of matter. So things like atoms and molecules are both considered particles. So now you know about atoms, molecules, and particles. Let's move on to number 2 on the list, the classifications of matter. There are a couple of major classifications of matter: the states of matter and the compositions of matter. The states of matter describe how the particles are arranged, whereas the compositions of matter will describe the types of particles that are present. There are 3 different states of matter that you need to know: solids, liquids, and gases. Solids have a definite shape and volume, and this happens because the molecules pack tightly together and cannot move around each other. There are 2 types of solid: crystalline and amorphous. In crystalline solids, molecules have an organized structure with a repeated pattern known as a lattice. Examples would be diamonds and quartz, and even things like snowflakes and table salt, because all of the molecules are in this nice repeated pattern. The second type are amorphous solids, where there's no repeating pattern for the molecules. So things like rubber and plastic, where the molecules kind of randomly pack together and there's no repeated pattern whatsoever, would be considered amorphous. Next are liquids, and these assume the shape of their container. So they don't have a definite shape, but they still have a definite volume. This occurs because while the molecules are still stuck together like they are in solids, they aren't fixed in place, and they can move freely around each other, making it so that they can conform to the shape of their container. Think about a tall, skinny glass of water and pouring this into a wider, short glass. The water molecules stay together and retain the same volume, but they can form to the shape of its container. The last are gases, and these have no definite shape and have no definite volume. While gas molecules will collide and there are some interactions there, they basically just fly around each other and don't stick together, and therefore they can conform to both the shape and the volume of whatever container the gas is in. Think of a piston moving up and down where the number of air molecules will stay the same, but as the piston moves, the volume the air takes up will change. As it moves up, the volume or space of the container will increase and the gas will then expand to fill the space. As it moves down, the volume of the container decreases and the air molecules will then get pushed down with it, or compressed. The ability to change the volume of gases make them compressible, whereas solids and liquids are considered incompressible. And technically, there's a fourth state of matter called plasma, and it makes up 99% of all of the matter in our known universe, but that's way beyond the scope of this chemistry course and really most science courses, so don't worry about it. Alright, so the other classification are the compositions of matter. The easiest way to learn this is to break it down using a flowchart with all matter at the top of that flowchart. Next is to determine how many substances are present. Is there only one substance present? Or are there two or more substances present? Remember, substances are anything that retain constant chemical composition and properties. If only one substance is present, then great, it's considered a pure substance. These can either be elements, which are fundamental substances that cannot be broken down into simpler substances, or they can be compounds, which are composed of two or more elements. And these can be broken down into simpler substances. Examples of elements would be H2, and also O and O2. Even though H2 and O2 both have multiple atoms making them molecules, they cannot be broken down into simpler substances, therefore making them elements and not compounds. You can't break down hydrogen into something simpler than hydrogen, and same goes for oxygen. Some examples of compounds would be H2O or NaCl or C6H12O6. Really just any molecule where there's multiple elements present. However, if there are two or more substances present, then it's considered a mixture. And then mixtures can be broken down further into either homogeneous mixtures or heterogeneous mixtures. Homogeneous mixtures appear uniform throughout, and all the substances within mix really nicely with each other. Water and salt would be a great example of this, because if you throw in some salt and water and you give it a mix, the salt will dissolve and then you're left with this really clean solution. On the other hand, heterogeneous mixtures have visually distinguishable components. Water mixed with some dirt would be a great example, because you can see the chunks of dirt floating in the water and you can clearly see what is water and what is dirt. Understand this chart and you'll crush any question regarding the compositions of matter. And that wraps up the two major classifications of matter. So let's move on to number 3, the properties of matter. There are two types of properties and changes for matter: physical and chemical. Physical properties are characteristics such as boiling point, hardness, odor, and density that are observed without changing the composition of the substance. Physical changes happen when the physical state or appearance changes, but not the composition. No new substances are created during a physical change. Examples of a physical change would be water boiling, because it's going from a liquid to a gas, which means that's changing state, or mixing coffee and cream together, because you're changing the appearance of these two substances, but you're not creating or changing any of these substances, you're just mixing them together. On the other hand, chemical properties describe the way substances can react together to form new substances. And as a chemical change occurs, the composition of matter is altered via a chemical reaction. Examples of chemical changes include gasoline burning, where octane and oxygen react to form CO2 and water, or photosynthesis, where plants make their own food and oxygen from CO2 and water. Furthermore, chemists and engineers often need to separate mixtures out into their individual components. The way that they do this is usually utilizing physical and chemical properties of the substances that are involved. Now, separation of mixtures is a whole subsection of chemical engineering and chemistry altogether. So while I want you to be familiar with these definitions, don't sweat it if you don't have an in-depth understanding right now. 3 common separation techniques are decant, filtration, and distillation. Decant is separation of a liquid and a solid by carefully pouring the liquid into a new container while retaining the solid in the original container. Filtration is the separation of a liquid and a solid where a mixture is poured through a porous material and the liquid can freely pass through the material while the solid can't. And last is distillation, which is the separation of components within a liquid mixture. Basically, if the components of a liquid have different boiling points, chemists can heat up the liquid to a certain point where one component will then boil, and they can collect that gas and condense it down back into a different container and retain the composition with the higher boiling point, therefore separating out the 2 mixtures. So that ends our first lesson on the basics of matter and chemistry. In the next lesson, we'll go over some of the most important topics in all of science and engineering: units of measurement and dimensional analysis. Thank you for watching, and I hope you learned a thing or two about science.